Okay, class, we are doing 10.8 and I'm just going to go ahead and use from the book because it makes it easier because it's a bunch of graphs. So we're going to be at the last section comparing linear, exponential, and quadratic models. So down here you see three graphs. Obviously this is a line, so it's linear. Exponential, you can see the way it curves and increases, or it can decrease normally fairly fast. And then the quadratic, you can see the symmetry. It has a vertex and it's equal on each side of the vertex. So they look very different. And the form that you write them in is very different. So a line is y equals mx plus b. Exponential function, y equals a, b to the x. And quadratic function is y equals ax squared plus bx plus c. Okay, so we're going to go ahead and they're going to ask you to define whether something is a linear function, an exponential function, or quadratic. And there are ways to look and see fairly quickly and eliminate, okay? So the first one we're looking at is A. We're looking at the numbers. We've got -4 and 1 over 32, -2 and 1 over 8, 0 1/2, 2, 2, 4, 8. One of the things that's kind of a little tip is exponential functions normally include a lot of fractions. So when I see a lot of fractions like this and they're going at different rates, then I tend to think this is an exponential function. But you would plot those points and you can see that obviously this is an exponential function. But just even by looking at the y values, I can see that they're not going at the same rate. Between 2 and 8 is 6, between 1/2 and 2 is 1 1/2, so I know that's not a line, okay? The second one then is, what did we remember about quadratics? They have a lot of repeating from the vertex, they repeat the y's. And lines don't. So if I'm looking here at B, I see -4, 1, -2, 2, 0, 3, 2, 4, 4, 5. I have no repeating y values at all. So to me, this looks like it would be a line. You would plot the points, and you can see if you plot the points, you just have a straight line. Okay, so these are little tips that you're looking for. So you can have an idea and you prove it by graphing it, or as we go on, you'll see there's other ways to prove it. Then the last one obviously has to be a quadratic, and that's what I was trying to say to you. Look here, you've got -4, 5, -2, 2, 0, 1. Then at 2, you've got 2, just like at -2, you have 2. At 4, you have 5, just like at -4, you have 5. So that kind of gives you an idea that it is a quadratic. So if you plot it, you can see that you have a quadratic. So those things will give you an idea of what you're looking at. Okay, the next page, moving on real quick, is we're looking at differences and ratios, how to tell if something is a linear, an exponential, quadratic. All right, the easiest is a line. Okay, so you look and you have your ordered pairs, -1, 2, 0, 5, 1, 8, and 2, 11. So the way that you can tell for sure is you can see there's no fractions here, so I don't think it's an exponential. And you check and see. You take the difference of the second minus the first, so be real careful of that. This is the first, this is the second, the third, fourth. So 5 minus 2 is 3. Then here, 8 minus 5 is 3. And then 11 minus 8 is 3. They all have a difference of 3. Or from the bottom to the top, you're adding 3. But that makes it a line. It means that's the slope. It's the same. So it's real easy to see a linear function. A lot of times they don't have a bunch of fractions, and you can see real quick it's going at the same rate. An exponential function, a tip-off to look at, it doesn't mean that a quadratic and a line can't have fractions, but you can see real quick that from a half to a quarter, you can see, and from 1 to 1/2 and from 2 to 1, it's not the same rate. So an exponential function isn't the difference, it's division, it's the ratio. So again, the second minus the first, so I take 1/2 and I divide it by 1/4 because this is 1/4 and I get 2. Then I take 1 and divide it by 1/2, which is going to give me 2. And I take a 2 and divide it by 1 and I get 2. So the difference of the ratios, the fraction, is a 2. That's how you can see it's an exponential function. It's not adding, it's the fraction, it's a ratio, okay? Then a quadratic is different. You look here and you can see real quick it doesn't have a bunch of fractions, so you should think, okay, line or quadratic. I know it's a quadratic, but say you're on a test or you're doing homework. So you look and you can see 2 minus 5 is -3, 1 minus 2 is -1, 2 minus 1 is 1, 5 minus 2 is 3. They do not have the same difference in the y values, so I know it's not a line. All right. Quadratic means we have an exponent of 2. The way that you can prove something's a quadratic is the second difference. The second time around, you will get all the same numbers. So now I take this difference, -1 minus -3, so it becomes -1 plus 3, 2. 1 minus -1, so 1 plus 1 is 2. 3 minus 1 is 2. So the difference here is 2. So I can prove now that this is a quadratic. So you can see how you can prove between a linear function, an exponential function, a quadratic function. And I wrote here the second value minus the first value, okay? So that's going to be for a quadratic and a linear. And then over here, it's going to be the second value divided by the first value, okay? Just like here, fraction. That's the second value divided by the first value. And you just got to practice. As you practice, you'll get better at it, okay? So again, example 2, we're going to identify functions using differences or ratios, okay? So the only one that uses a ratio, again, is the exponential function. So we got here, extend the table to find the y value for the next x value. So I've got a and b. Let me start with b because it's easier. I can see that this is a line. So we'll do the easiest one first. Okay, if I say 1 minus -2, I get 3. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. So they want you to write the next value. So to get 3, I'm going to say 10 plus 3 is going to give me 13. So when x is 13, my y value is 3. That's the easiest one, a line. You're just adding whatever the slope is. So you add 3 more. Now here, I can see, okay, first difference, second difference. I know this is a quadratic. All right, so they want to know, what's the y value when x is 3? So I'm looking here, and I know that I'm -6, I'm adding nothing, so I get -6. Then I'm adding 2, and I get -4. I'm adding 4. -4 plus 4 is 0. 0 plus 6 is 6. So they want to know what the next value is for y. So when x is 3, I'm going to take 6, and I know that these are all going up by 2, so this will be 8. So then 6 plus 8 right here is going to be 14. Okay? So look at the pattern. As long as you can figure out these patterns, you'll be fine. And remember, you learn as you do your homework and you start doing it, and it starts making more and more sense. Okay? So that's if they tell you to identify functions using differences or ratios. So we're going to move on to the third example. Okay? Okay, so Write an equation for a function. Tell whether the table of values represent a linear function, an exponential function, or a quadratic. So those are your choices, linear, exponential, or a quadratic. Then write an equation. So they want to always read the instructions for the function, especially now that you're online. Just read what it's asking, okay? All right, so they give you x and y, so I've got a -2 and a 2, a -1.5, a 0, 0, 1.5, and 2 and 2. So just real quick, even before I go any further, I can tell at -1 I get a half, and 1 I get a half, at -2 at 2, 2 and 2. So I know that this is a quadratic. That's what I mean. You have to be a detective in math, okay? It's not a linear. They're not going at the same rate, okay? And the fact that these are repeating, that means the vertex is at 0, 0. So that helps you when you can spot these things. And determine which type of function the table of values represents. I already kind of knew, so I'm going to prove it. I know a quadratic is a second difference. So I have to go the second difference minus the first. So 0.5 minus 2. So a half minus 2 is -1.5. Then I go to the next one, 0 minus a half. If I've got 0 and I take away a half, I've got -half. Then the next one, 0.5 minus 0. If I've got a half and I take nothing away, I've got a half. And then the last one, 2 minus 0.5. 2 minus a half is 1.5. Okay, so like I said on the quadratic, the first difference is not the same. So that means the second difference will be. So I do the same thing now. Here, -0.5, the second difference, minus the first difference. So I've got a double negative, so that's going to be addition. So -half plus 1.5 is going to give me 1, which is right here. Then the next one is 0.5 minus -0.5. A half plus a half is 1. So you can see so far the first two. Third one should be the same thing. The second, 1.5 minus the first, 0.5. So 1.5 minus a half is 1. So there you go, I've proved it, that it is a quadratic. So now that I know it's a quadratic's basic function is y equals ax squared, okay? So I need to find what a is. I don't know that, but I do have ordered pairs here for this original function. So we're looking here, I've got -2, 2, -1, 0.5, don't use 0, 0 because that's not going to help you, 1.5 and 2 and 2. So I went ahead and picked 1.5. So my x is 1 and y is 0.5, and it's not me, the book did it, okay? So you are going to plug in. You know that y is a half, 0.5 equals a, we're looking for a, and we know that x is 1 squared. Anything squared, 1, it could be 1 to the 100th power, it's still going to be 1. So I've got 0.5 equals a times 1, which is just a. So a is 0.5. That's all you need to do to find, write an equation for a quadratic. So now I go y equals 0.5 x squared. And there it is. If you have the right function written, then you can plug all these numbers in and they'll be right. And you get 0, 0, you get all the numbers that they have down, okay? 2, you get 2. If you plugged it in, it would work out. All right? So remember, looking at the table, you should have a clue. You can tell real quick if it's a line. If it's not a line, then look at it. Does it have a bunch of fractions? It's most probably an exponential. Even though this has fractions, quadratics can have fractions. Look and see if you can see symmetry. I could see symmetry right away. So I could tell this was a quadratic. It didn't take long to figure that out. Okay, last one we're going to do is a word problem, your favorite, I know. It's not too bad, actually. So we'll follow along with the example in the book and solve this multi-step word problem. Okay? Okay, so here we go. The table shows the breathing rates Y. So the breathing rates are the Y in liters of air per minute. So they're always going to tell in a word problem what everything means, okay? Traveling at different speeds X. So X is the speed of the cyclist in miles per hour. So it's very clear. I'm going to tell you exactly what everything is. Tell whether the data can be modeled by a linear function, an exponential function, or quadratic function, and write an equation for the function. Okay, so I'm looking at the Y values, and obviously for this to be true with the differences, the X's have to be going at the same rate. They're all increasing by 1. So as long as that's happening, this will be true. Okay, so 51.4 to 57.1 to 63.3 to 70.3 to 78. I can tell that's not a line. Okay, so I look real quick for the easiest. It's not increasing by the same rate, so it's not a line. Rule that out. Okay, so it does have a bunch of fractions, so my suspicion is it's an exponential. So that's what I would try real quick. You just do the differences of a couple. If it's true, then you know you have an exponential. If it's not, you go on to a quadratic. So they show that they did that. Okay, they graphed it. Okay, so they did it by 20, 21, 22, because along the X is the speed of the cyclist, and we only have from 20 to 25, so they did it by ones. Then here, you don't need anything lower than 50. They put the 0 here, but basically you're looking at 50 all the way to 80, so they did it by tens. Okay, so that's where you change your X and Y values on your graph to make it fit. Then when you plot it, you can see it's going like an exponential, the way it's got that little curve like that. So it's definitely not a quadratic. So then now that you know it's an exponential, you take the second difference. This is the second, this is the first. You divide the first into the second. So 57.1 divided by 51.4 gives you 1.11. They did the same thing. 63.3 divided by 57.1 gives you 1.11. And when you do them all, don't just check one. You have to make sure the whole thing does the same. That proves that the difference, the ratio, the fraction is 1.1. It's the same. So I know it's an exponential function. So then this in an exponential function, because we write an exponential, y equals a b to the x, okay? So when you find, let me move this, make sure you can see it very good. Hold on, I'm going to move this up a little bit like that. There we go. That's very clear now. So when you find that difference, the ratio difference, that is the b of the exponential function. So you found b. Of course, we always need to find a. That's what we're looking for. All right. This is the thing we're looking for. Do we have values that we can plug in for x and y? Yes, you can use an ordered pair. They decided to use the first one. X is 20 and y is 51.4. So now you can plug everything in. Okay. So into y, they've plugged 51.4 equals a. A is what we're looking for. We know b, parentheses, put a parentheses, is 1.11 raised to the 20th power. Okay, and then you just solve for a. So you would figure what this is, 1.1 raised to the 20th, divide it into 51.4. On your fraction, you might want to put everything around parentheses to separate the top from the bottom so you get the correct answer. You shouldn't get anything super crazy. You should be able to look at your graph and know it's not going to be like a super large number or negative number. So it turns out that a is 6.38. So now you can go back and write the function. You know a, you found out b, and then the X is the time. So if I want to know the speed of the cyclist, the breathing rate at 30, I would just plug a 30 in for X and I would be able to answer any question. All right, guys, that's